Hi guys, welcome to the channel. Hope you are doing well. So in this video I am going to solve a new HackerRank problem that is called Sherlock and Anagrams. So this problem is available on HackerRank. So there will be two parts of this problem solving video. So in the first part, that is this one, I will show you how you can approach solving this problem and how you can start thinking to solve this problem. And in the second part, that is in the next video, I will show you how you can code it using Python programming language on HackerRank platform. I will show you live coding and then make the submission, and we'll see how all the test cases are passing or not. Okay, so let's start with the video. The problem statement says there are two strings are anagrams of each other if the letters of one string can be rearranged to form the other string. So let's say you have two strings. Let's say you have one string ABC, ABC, okay, and the other string is given to you BCA, okay. So if you rearrange the characters of this string or letters of this string, you will easily get ABC, okay. And this ABC is nothing but this string. Hence we can say that these two strings are anagrams to each other, okay. That is the first sentence what the problem statement is saying. Now, given a string, find the number of pairs of substrings of the string. So we have to find all the possible substrings of this particular string, and we have to check from all the substrings. We have to count the number of pairs that are anagrams of each other. So let's say if we have the string ABC, will generate all the substrings A, AB, ABC, then BCC, okay. And in this list of substring, we have to find pair of substring that are anagram to each other, okay. So in this pair, in this list of substring, there are no any substring that are anagram to each other, okay. So here an example is given. Let's say we have a string mom, MOM. Now if you get all the substring of this particular string mom, it would be M, then MO, then MOM. Next would be OM, sorry, O, then OM, and then finally we will have M. So these are all the possible substrings of this string mom. So if you check here, this M and this M, they are exactly same. So they are anagram to each other. If you have single character, single letter, they will always be anagram to each other. Now if we check this MO and this OM, if you rearrange the letter of one of them, then it will become the other. So these are also one pair of anagram, okay. These are pair of anagram. So in this string there are over total two pairs of anagram possible, and hence we have to display the value 2 as the output of the program, okay. So let's start solving with some other, how we can solve. We'll see an example. So let's just solve this one. So let's start with an example, okay. So let's say we have a string ABBA. Now in order to check the string, first we will have to find all the possible, find, this is step 1, find all the possible substrings, okay. And for that, how we can do, we can take put one pointer or one any pointer at index this, and next pointer we can put you for iterating through all the characters, okay. So if we check here, we will have uh, A, AB, ABB, ABBA, and then once by keeping first pointer here and iterating through all the characters of this string, now our first character will move to first pointer will move at this character. Okay, now we will start with B, so we'll have first B, then BB, then BBA. Okay, now our pointer will be here, first pointer will be here, and second point, using second pointer we will iterate onwards to this point. So again we will have B, and then BA, B, and then BA, and finally our pointer will be here, first pointer will be here, so we will have left with A. Okay, so these are all the possible substrings over here. Now our next job is to find all the possible pairs. So first we take the first value of this value of this substrings. We take A as a substring and we check how many all possible pairs are available here that forms anagram. So if you check A, if you take A with AB, it will not be anagram. It will, for a single character string, the anagram is only possible with another single character string, which is nothing but this. Okay, so AA, we form one anagram pair. This is one anagram pair. Now with AB, how many possible substrings are there which can be formed, which can be anagrammatic pair? So AB, and then we can have BA as the next. If you rearrange the characters of this string, you will get AB again. So we have AB comma BA, and they are another anagrammatic pair. Similarly ABB, we have BBA. Okay, so we have ABB and then BBA. This is another anagrammatic pair. For next, ABBA is a single string that is the same as parent string, so there won't be any other substring representing this. There will be this will be only one, so there won't be any anagrammatic pair for this. Now next is our B. Okay, so is there any other B? Yes, there is another B. This is one more anagrammatic pair. Now we check with BB. Is there any other substring that is BB? No, there is no. So there won't be any anagrammatic pair for this. So we are done with all the characters. So finally we have total 1, 2, 3 and 4 anagrammatic pair here. 4 anagrammatic pair. Okay, and we have to return the value. The third step is to return the value 4 as the output of the program. Okay, so let's see how you will program it in the Python. So we will not write code, but simply an overview of this problem solving. Okay, so for the first step, we have to get all the substrings possible. In order to get all the substrings possible, you will have to use at least 2 pointers. For using 2 pointers, you will have to use 2 for loops. Okay, so you will iterate for the first for I in range. Okay, total characters in the string, let's say it is n till n. This will be the first pointer that will be constant for the first iteration, and again second iteration it will increase. Then we will have for j in range. It will start not from 0 now. Now this will start from I plus 1 and go till n plus 1. Okay, and from here you can find all the possible substring as I to j. This is your substring for every iteration, for every value of j and I. Okay, you will get, and you can append it, you can store it, this value in some list. This is your first step. Now the next step is to get all the anagrammatic pairs. Now let's say you have a list, okay, that contains all the possible substrings. Let's take the example of the above one only. We have a list of substrings as A, AB, ABB, ABBA, BBB, and then BBA, then BBA, and then finally A. These are all possible substrings of the parent string. Let's assume this. Now, in order to find the pair of anagram, you have to check for this particular first value of first substring. You will check with every other substrings available in the list and see if the two pairs are anagram of each other. In order to check for if they are anagrams of each other, for example ABB and BBA, you will have to, if you want to check if they are anagrams of each other or not, so you will have to sort them so that you can check. So if this is already sorted ABB, and you will sort this string and see if they are exactly same. If they are exactly same, then they are anagrammatic pair. If they are not, they are not anagrammatic pair. Okay, so here again, for each substring you will have to iterate through all other substring of the list. So you will need two for loops again here. Okay, two for loops for I in something and for j in something. Okay, you will need two for loops here, and then again after that, once you have the pair of substrings, you will sort them. Sort the substring 1 and sort the substring 2. Okay, now once you have sorted and seen that they are anagrammatic pair, the sorted order of the string matches exactly, you will append it some in, put it in some list and check how many total anagrammatic pairs are there. You will check the length of anagrammatic pair, and then what is the value of that particular list. That will be your final answer. That is length of anagrammatic pair. Okay, now here is one thing. So if you see in the first part of solving this problem, you have two for loop that is running from for n characters, that is running n times. So we have time complexity here as O of n square. Okay, now in the second step, if you see, we need two for loops in order to get the pairs of substring. Now, once you have the substring, you are going to sort the substrings and check if they are equal or not. So, sorting also takes some amount of time. Sorting is also of order O uh, log n. Not exactly log n, it's O of n log n on an average. Okay, the time complexity of sorted method in Python. On an average, the time complexity is O of n log n. Okay, so here if you check the time complexity, you have O of n, and then here again O of n log n. So you will get time complexity of O of n cube log n, which is too high, which is very expensive. You are taking n cube of times minimum to solve the second part of this particular problem, which is expensive. And I think on the HackerRank platform, this particular solution approach will not pass all the test cases because of time complexity. Okay, so what can be other way to solve this problem which reduces the time complexity? Because for first part, in any way we are going to take O of n square in any way. Okay, so we have to reduce this second part as well, so that it is either O of n square or less. So let's see how we can solve this problem. Okay, now second approach. The first part is anyway going to be there. You will have to get all the substring, possible substring from the given strings. Okay, so you will use two for loops and for j. And now once you have when you say an anagrammatic pair AB and BA, if When you sort one of them and you get the same value, then you say this is anagrammatic pair. Anagrammatic pair. Okay. Now, if we have in the given list of substrings, if we have two AB after sorting, so count of AB is 2 after sorting the substrings, then we can say we can have one anagrammatic pair. Okay. Now let's say if you have 3 AB, okay, situated in this substring list, then how many anagrammatic pair you can make? So you can make first one with this one. First one you can make AB with AB. Second you can make this AB with this AB, and third you can make this AB with this AB. Okay, so here in this case, if you have 3 same substring, you can have 3 anagrammatic pairs. Okay, what if there are 4 same substrings AB, AB, and AB? How many anagrammatic pairs can you make? First, with this you can combine this and make. You can make this pair. You can make this pair. Okay. In the second case, you can make this pair. You can make this pair. How many it happened? 1, 2, 3, 4, 5, and then in the last case you can make this pair. So there are total 6 anagrammatic pairs here. Okay. So are you able to observe something? If you have two same substring, you are getting one anagrammatic pair. So this is anagrammatic pair and count of substring. Okay. If you have 2 substrings, you have one anagrammatic pair. If you have 3, you have 3 anagrammatic pair. Okay. If you have 4, you have 6 anagrammatic pairs. Are you able to get it? And if you have one substring, you will get 0 anagrammatic pair. Right? Can you observe some pattern over here? So if you see, when there is 0 anagrammatic pairs, okay, for this case you have only one substring. Okay. Now for 2, count of substring is 2, you have one anagrammatic pair. Now if you see this 1, how is this 1 coming? This is nothing but coming from here. Okay. Now if you see, when there are 3 substrings, the anagrammatic pair is, the count is 3. Okay. How is this 3 coming? If you see, this 1 plus this 2 is your 3. For 6, how is it coming? This is, if you see, 1 plus 2, 2 plus 3 counts to be 6. Similarly, if you have 5 total 5 count of substring, you will get how many anagrammatic pair? 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. You will get 10 anagrammatic pairs. Let's prove this, that if you have 5 same substrings, okay, you will get 10 anagrammatic pairs. And once you are able to solve this, you can generalize this relation. Okay, so you have 1, 2, 3, 4, okay, 5, 6, 7, 8, 9, and finally 10. Okay, so there are 10 anagrammatic pairs. Okay, so from this, what we can do, we can think of storing this particular substring. We can store this substring and we can check what is the count of this particular substring. If there is 2 count of this particular substring, we can say there is 1 pair. If there are 3 count of this substring, we can say there is 3 anagrammatic pairs. Okay, so we can maintain a dictionary. And maintain the count of each substring. What is the count? Okay, and on the basis of this count, if the count is 4, we can sum up all the values before 4, and that will be your number of anagrammatic pair here. Okay, so looping through the list of substrings 2 times and then sorting the value again is now sorted. Okay, so now, alright guys, so we have got the number of anagrammatic pair over here. Okay, now let's again check the time complexity of this. Okay, so here you will get the substring. Let's say you got a substring, okay, a b, or let's say you got a ba, okay, and in the initial you might have got ab, so we can store the counter of ab equal to sum. Already we have one time. Okay, now you have a substring ba. Now you will want to sort this, it will become ba. Okay, and then you will check if this particular value is available in this dictionary. If it is available, then increment the counter by 1. Okay, and if it is not, insert this in this dictionary and then assign the counter as 1. Okay, now here again if you see, we have o of n, o of n, o of n square, and since you are using sorted over here in order to sort this substring, at the worst case you will get the longest substring, that is our string itself, and in that case the sorting order would be again o of log n. And here again if you check the time complexity, o of n, o of n, and then again o of n log n, so we will have in the worst case o of n cube log n, and same was in the above case as well. Actually I wrote o of n cube, but it will be o of n cube log n. Okay, I wrote the same, correct. So again here also we are not able to minimize the time complexity if you see. Okay, so can you think of something so that we are able to reduce the time complexity and bring it down to either o of n cube or o of n square? Can you think of something? Pause the video and give it a thought. Try thinking how you can do it. Try solving it on your own. If you are not able to solve, I have discussed that approach as well in this video. So first think for a couple of minutes. So alright guys, I hope you might have thought, and if you were able to solve, that's great. If you are not, let's discuss another solution. Okay, so if you are aware of, okay, any character in computer can be coded into some integer, that is the ASCII value of this particular character. Every character in computer has some ASCII value or its integer representation available. Okay, so using this concept of every integer or every character having its integer representation in computer, we can try to maintain a dictionary where we will check the occurrence of each character. Okay, where we will store the occurrence of each character. Okay, so for it, let's discuss through this an example. Okay, let's say you are into the for loop. Okay, and you got your first substring as a. Okay, and you have, let's say you have frequency counter as a list where you have stored, and since there are 26 alphabets. Okay, we initiate this with into 26, so here we will have 0 0 0 26 times. Okay, 26 times, 26 times. Okay, now let's say if in the current substring there is presence of a, we will check if this is available here. Okay, if this is available, sorry, this won't be available obviously. So if this is, we will assign the counter, we will increase the frequency of this. So here we will have for for substring for character value a we will have 1 and then remaining we have 0. Okay, this is your, this particular list is representing the substring a. Okay, now when you go in the, since there are first is I and second is j iteration for loop, now for j equal to uh, obviously the first or you can say the zeroth value, you are getting this substring. Okay, for the next iteration, if you have the string as this, okay, for the next iteration what you will get, you will get a, you got a for the first j, and when the j increments you will get the value b. You have this frequency counter. Okay, you have this frequency counter. Okay, this frequency counter till now is representing only the value a, the substring a. Now once you have b, okay, for b you will again represent it in the frequency counter. So this already you have. Okay, and for b what you will do, you will make the counter of frequency of b here. So now this list is representing which substring, a b. Okay, since this frequency of a is also available here, so the next substring, this is being represented, this list is being represented by next substring ab. Okay, let's say if you get another b in the next term abb, you have this one, you have stored this substring in some list or maybe some dictionary. You have this list as well stored which is representing string ab, this representing a. Now in the next iteration you have not removed this, so you will initiate this particular frequency counter after, for after the first loop. Here you will initiate this frequency counter. So for every starting index, starting pointer, you will have a frequency counter. Now for this, when you get to this, when your j gets here, you have another b and another b again. So the frequency of b will increase here. Now a b b will be represented by 1 and the frequency of b will increase to 2 and then remaining 0. Okay, so this is representing your one substring. Okay, so this is the idea how you can use the integer representation of each character in computer, and then you can solve this problem. So I'll give you a rough idea how you can approach. So you'll start with a for loop for I in n, and then for j in I to n. Okay, here you will have a frequency counter, 0 into 26. Now you will check, you will maintain a frequency map. You will maintain two things. First is frequency map. Okay, that will be a dictionary, and another is anagrammatic pair counter, a variable anagrammatic pair counter with 0. Okay, now, or even if you don't maintain it right away, it will work. So right now we have, if we will check, if the first one will get for this string, you will get this value. So if this particular a or ordinance of a, okay, it will be 1 second. Okay guys, so it will be, yeah, so if this a, this particular value is in between, we will check first it is a character, sorry, alphabet, English alphabet or not. If it is in between z and greater than equal to a, English alphabet, and if it is there, we will check, we will assign a frequency to it. So we will say frequency, and there is one function ord that converts any character into its integer representation. This is in Python. Okay, so we will say ord of given s of, let's say s is your string, so given this j index, at j index, if we will say frequency of this, and we will subtract. So what happens in Python, sorry, not in Python, in computer, the integer representation starts from somewhere. So let's say your alphabets representation starts from 72, okay, and it goes till 72 plus 26 till 98 or 97. Okay, if it goes, let's say if you have your character b, that is represented by 73 b. Now in order to represent this integer, you want to get the integer value for this from English alphabet which falls at second position. So you will get this and subtract the value of a from where the English alphabet starts, and you will get the value of 1, and this 1 represents the index second in Python list. Okay, in English alphabet this is at second number, so second, this value 1 represents at second number. Okay, and if there is a only, then you will get 0th index. So you will get here minus ordinance ord of a, and you will increment the frequency counter. Sorry, you will increment the frequency counter. Okay, plus equal to 1. Okay, so if b, if any particular character is already available in the frequency counter, then it will increase by 1. If it is not, it will, if 0, then it will increase to 1. Okay, so that's the idea. This way you will maintain the, what is it, the frequency counter. And okay, and after this, once you have, you can convert, you can make it a tuple. So we'll, for simplicity, we'll make a tuple of actually this will be inside your for j loop only, inside this j loop only, in this line only we are going. So we'll have frequency, we can have a frequency tuple that will convert this into a tuple representation. Instead of list, it will represent a tuple, and then add it in the frequency map. Okay, if this particular frequency tuple is available in frequency map, here we have initialized a frequency map. If it is available, then if frequency tuple in frequency map, okay, then increase the counter by 1. If it is not, we will assign it frequency tuple inside frequency map, we will assign the new key and value pair. Okay, so in this way we can solve. In the next video, I will show you the solution using all the 3 parts, and we'll see which of the 3 solution passes all the test cases. Okay, so here is one question for you guys. Okay, so I have converted this particular list of frequency. Initially frequency counter we have in terms of list. Okay, now I have converted it into tuple. Okay, now the question is, why did we convert this list, the frequency list, into tuple? Can any one of you tuple and not directly store it as a list in the dictionary? Why did we convert into tuple and then store it in the dictionary? Can any one of you think? And please let me know in the comment section if you know the answer or if you are able to think on it. Okay, if not, try doing some research, and in the next video I will explain the exact solution, the correct answer, that why have we converted this into tuple and not in list. Why are we storing it, the particular value, in dictionary as a tuple and not as a list. Okay, so that's it for this video, guys. Hope you like the video. Thank you for watching the video. All right, bye.